Hey everyone, welcome back to my Calculus 2 series. In today's lesson, we're going to be talking about power series. So power series are basically a different type of series that we haven't yet encountered, but the concepts are all going to stay the same throughout this entire series unit. So it's just a different type of series. And this power series, we can write them as starting from n equals 0 to infinity. You can already see the difference. First, we used to start off with n equals 1, but for power series the convention is that we start with n equals 0, and then for the values that are going to be summed up, well, we're going to sum up c of n and then x to the power of n. And essentially c of n, these are going to be the coefficients. All the coefficients can be different, so c1 can be different than c2, can be different from c3, so they can all be different. And then xn is basically x to the power of the n that we're currently on through the iteration. And the cool thing about power series is that they can be divergent for some values of x, and then they can be convergent for other values of x. Before we were dealing with series, they basically wouldn't have a variable other than n, which was being set through like the iterations as we went through the sigma. However, now we have this other variable x, and basically we don't know the value of it, and what we try and do in power series is we try and compute the values for which this power series is going to be convergent, and for which values of x this series is going to be divergent. So a more general way of writing this power series is by writing it like this. So we would have, again, from n equals 0 to infinity, c of n, and then we would have x minus a to the power of n. Basically the only difference on this one is that this is kind of the more general way to write it, and this is going to be a power series centered about a. So that's all this is. This x minus a just tells us where kind of the center of this series is. If you remember, I was previously talking about what we want to do for these power series is, because there's this variable x, we want to find for what values of x is this series going to be convergent or divergent. So for this example, we're asked to find for when it is convergent, but likewise they can ask you to find when it is divergent. Now the way we would go about this is by using, again, our trusty ratio test. If you're not proficient with the ratio test or you don't really understand it, go back a couple of videos, watch it. It is very, very useful, and we're going to be using it a lot. If you remember, the ratio test basically tells us to take the limit as n approaches infinity of a n plus 1 over a of n. And that's exactly what we're going to do here. And then we're also going to apply those three conditions that we saw from the ratio test to figure out for what values of x is this series going to be convergent. So firstly, let's go ahead and find what a of n a n plus 1 is going to be over a of n. So this is going to be equivalent to the limit as n approaches infinity, and I'm going to write this as just, again, a of n plus 1 times 1 over a of n. I'm just going to write it like that just so we don't have like layered division, but it's going to look like this. We're going to have x minus 3 n plus 1 over n plus 1 times n over x minus 3 power of n. And now we can see that we can cross this and this out and basically be left with just x minus 3 over here. So this will simplify to the limit as n approaches infinity of x minus 3 times n over n plus 1. And now this value right here, this x minus 3, is not dependent on the value of n, so we're going to bring it outside of the limit. However, we are going to keep the absolute value around it because, again, we don't really know what the value of x is. So this is going to equal to the absolute value of x minus 3, and then we're still going to multiply by this limit as n approaches infinity of n over n plus 1. And now, again, if you're not good with limits, you should probably go back and review them, but this is pretty obvious that this limit is going to be approaching 1. So we're going to get that x minus 3 times 1, and that's basically equal to the absolute value of x minus 3. And that's what the question asked us to find for what values of x is this series convergent. And you might not know why we applied the ratio test yet, but if you remember, the ratio test that says that a series is convergent if this limit right here is going to be less than 1. So we want this limit to be less than 1, and then it will be absolutely convergent or in this case, it would also mean that it is convergent, which inherently would mean that it is convergent as well. So we need to solve this right here for when the absolute value of x minus 3 is going to be less than 1. Well, how can we do that? Basically, this, because of the absolute value, it would give us two cases. One, when x minus 3 is less than positive 1, and the other case would be when x minus 3 is less than minus 1. These are the two cases. We want to solve both of them, and then we're going to get the values of x. So let's solve this one right here. Basically, all we need to do is bring this 3 over to the other side, and we're going to get that x is less than 4. And for this other condition, we're just going to solve, and it's going to leave us with x is less than 2. So for these two values of x, when x is between 2 and 4, this series right here will be convergent. And you can see why before from the ratio test I stressed that you understand it, because we will be using it for examples like this. If we look at the three possibilities that the power series can have, basically when we compute all that, these are the three possibilities that we can have. So if we're given any power series in this form right here, there are three possibilities. The first one is that the series converges only when x is equal to this value, meaning that we're essentially going to get a 0 here. And as we know, anything multiplied by 0 is always going to be less than 1, so it will converge for that value of a, and only that value of a. Now there are other series where they converge for all x, meaning any x value, it will converge. And then, as we saw from the previous example, there are also cases where we have this kind of like bound. And basically we say that there is a positive number r such that the series converges if, and then we have this expression over here, and then we say that it converges if it meets this expression, and then obviously if x is going to be greater than that value of r, well then it's going to diverge. So this value of r is called the radius of convergence. So if we go back, the radius of convergence here is going to be 1. Why? Again, because it fits this kind of form right here where we have x minus some sort of a value. In this case, the a value was 3, and then this was going to be our r value. So in this case, the radius was 1. However, with this definition, there also is another one, and it's the interval of convergence. Basically, all the interval of convergence asks us to find is kind of this right here. So it can be any of these four possibilities. Basically, all it is it's either the center value minus that radius, but we need to check. Sometimes it's excluded. These circular brackets mean that that value is excluded, and there are other times where that value is included. And likewise, for the other bound, well, it's basically the center value plus that radius. So if we think about it, if we were to have this center value, well, the interval would be like minus this radius and then plus this radius. So our interval would be somewhere here. Obviously, some intervals of convergence are larger than others. And yeah, we just basically, for the interval of convergence, we need to check whether these endpoints are convergent or divergent. If the endpoint is divergent, well then we need to include a circular bracket around that interval, because we can't include that point for the interval of convergence, obviously, because at that point it's divergent. However, if we check the endpoint and the series is convergent at that endpoint, well then we can add this square bracket around it, signifying that that endpoint is included in the interval of convergence. So now let's take a look at how we can apply everything that we've learned about the radius and the interval of convergence. So we are given this series right here, and we are asked to find the radius and interval of convergence. Obviously, the way we're going to go about this is by using the trusty ratio test. So what do? Well, we start off by taking the limit as n approaches infinity of a of n plus 1 over a of n. And again, these questions are set up the same way. You're just going to start off by using the ratio test. So let's go ahead and do that. So there you go. I have written out a of n plus 1 times the reciprocal of a of n. And now what I want to do is I want to simplify this. Basically, this will cross out, this will cross out, this will cross out, and this will cross out. And all we'll be left with is just a minus 3 and then an x. So this is going to equal to the limit as n approaches infinity, the absolute value of minus 3 times x times n plus 1 over the square root of n plus 2. these two terms are not dependent on n, so we can bring them out of this limit. However, once we bring minus 3 outside of these absolute value kind of brackets, we will need to apply them to it, so it will turn into a 3 because obviously the absolute value of minus 3 is 3. So this will equal to 3 times the absolute value of x. We keep the absolute value of x because, well, we don't know what the value of x is, so we just need to keep those around there. And then we want to multiply this by the limit as n approaches infinity of the square root of n plus 1 over the square root of n plus 2. And again, if you're not proficient with limits yet, I suggest you go back and review them, but this is going to equal to 1. So we're going to get that 3 times the absolute value of x times 1, and this is just going to equal to 3 times the absolute value of x. Now we have gotten down to this point, and we've basically found out what this limit equals to. And again, if you remember from the ratio test, the only time that the series is absolutely convergent is that if this is less than 1. So now that we have this expression kind of built, we need to find the radius and the interval of convergence. If we go back and look at how we find the radius of convergence, we basically need something in the form of this expression. And we kind of have that already. We, in a sense, have 3 absolute value of x minus 0 is less than 1. However, we have this extra 3 over here, which was not shown in this. I'm going to erase these arrows. But in this expression right here, it wasn't shown. So we need to get rid of that 3, and the way we can do that is by basically dividing out by it. So we're going to get that x is less than 1/3. And so there is our radius of convergence. So r is equal to 1/3. Now that we have the radius of convergence, we would need to find the interval of convergence. And like I said, the interval of convergence can be any one of these 4 kind of possibilities. So we need to find out which one of them it is. So let's go ahead and test the endpoints. First of all, we can start off with, obviously the bounds are going to be a minus r and then a plus r. So what is a? Well, a, like I said, was 0. And then minus r, well, it's just going to be minus 1/3 to 1/3. But we don't know what brackets to include. We don't know if we include these circular brackets or these brackets or any combination of them. So let's find this out. In the case that x is equal to minus 1/3, the series is going to look like this. So we go back to the original series that we had, which is right here, and we plug in x is equal to minus 1/3. So we're going to get that we have this series looking like minus 3 to the power of n. Obviously, before it was x to the n, but now we say x is equal to minus 1/3. So we put minus 1/3 there to the power of n over the square root of n plus 1. Obviously, this runs from n is equal to 0 to infinity. And now this can be simplified. These two can be kind of merged together. And basically, we're going to get that this is 1 to the n over the square root of n plus 1. And this can be simplified even further because 1 to the n, well, that's always going to be 1. So this is going to be 1 over the square root of n plus 1. Now, you can use the integral test, or you can use the comparison test with the p series of p equaling to 1/2. And in that case, we know that this series is actually going to be divergent. So because this series is divergent, we know that we must exclude the value of x equals to minus 1/3 from the interval of convergence. So that means that around here we would have a circular bracket. However, if x is equal to 1/3, then the series would look something like this. So it would be the same, however now we would have just 1/3 substituted in for x. And in this case, we would get that we have the alternating series that looks like this. So now, if you remember, for the alternating series, there are 2 conditions. The first one is that b of n plus 1 is going to be less than or equal to b of n. In this case, it is because, well, b of n plus 1 will be the square root of n plus 2. And then this will be less than the square root, or 1 over the square root of n plus 1, again, because the denominator is going to be larger here. So this condition is met, and the second condition for this series to be convergent is that the limit of b of n as n approaches infinity is equal to 0. And in this case, again, it is because we have the limit of 1 over the square root of n plus 1 as n approaches infinity. And in this case, again, it's going to equal to 0. So both conditions are met, meaning that for x is equal to 1/3, this series is going to be convergent. And because it is convergent, that means we can include it in the interval of convergence. So there you go. We have found both the radius of convergence right here and the interval of convergence right here. So that's it for this quick little introduction on power series and basically how to find their radius of convergence and intervals of convergence as well. Hopefully you guys enjoyed the video and have learned something from it. If this video has helped you out at all, please like and comment as to what I helped you out with. Like usual, if you're new to the channel, please like, comment, and subscribe. It's greatly appreciated. And yeah, I will catch you guys in another video.